Morning, everyone. Bright and early, 8:30. Thanks for showing up. I'm Brandon Chavez. I'm a product manager for Amazon EKS. This talk is called Deep Dive into Amazon EKS, but I think maybe a more appropriate title would be like Up to Speed with Amazon EKS. There are a number of sessions this week from our engineering team and customers that were definitely deeper dives into like specific areas of EKS. So we had a networking deep dive, we had a monitoring and alerting deep dive. We had some deep dives around how do we run EKS in a cross-account manner. And we'll kind of touch on a little bit of all of those things today, but at less depth, obviously, than the whole sessions that are dedicated to them. Cool. So let's go ahead and get started here. So what is on the agenda today? First of all, I want to talk about a little bit some customer use cases. So these are, for the most part, customers that are using EKS and talking about it at reInvent. So these are also talks you can go watch when you get back, or maybe you've already seen them this week, just to learn a little bit more about how they're thinking about EKS and how they're kind of moving towards using it in production or already using it in production. I'd also like to kind of talk a little bit about what's new for EKS. So we'll kind of get you up to speed. If the last time you looked at EKS was maybe around GA or sometime in the preview timeframe, we'll kind of ramp you up, fast forward you, and then we can talk about the current state of the system. We'll also talk about the EKS control plane and data plane. So from our perspective, that's everything that we run in our accounts and everything that you run in your accounts. And we'll talk about how those things work and how they're evolving. And then we'll also talk about networking and load balancing, which is always a fun topic for me. Pretty passionate about that stuff. And then I think the one thing we're not going to talk about is anything related to getting up to speed on Kubernetes. So we're kind of assuming that that's already something you're coming with expertise about. So let's get going. So kind of an obvious thing to touch on is like how are customers using this thing. So if I position EKS really quickly, this is basically the newest addition to our compute services, which includes things like Lambda, EC2, ECS, which if you look at it from that lens, like EKS is kind of a microcosm of those use cases, which is kind of to say a little bit of everything. So the top use case here is microservices. This is very obvious. This is all like net new applications. These are things that are born in the cloud, built using a 12-factor app pattern. These are kind of the things that Kubernetes kind of pushes you towards. We also see a lot of platform as a service, and this is, I'd say, primarily or mostly large enterprises that are building some tooling on top of Kubernetes for their developers, either to abstract away parts of Kubernetes or abstract it away entirely. But this is so that their development teams can kind of, all they think about is writing their code, maybe a Docker file, maybe a pod deployment spec, and they can get those things up and running on a platform based on Kubernetes pretty easily. Number 3, this is enterprise app migrations. These are like your tired and poor old Java applications sitting in a data center somewhere. This is a totally cool pattern, and this is a really basically lift and shift. So we do see a lot of folks gaining a lot of agility from just throwing an old app into a container and then using things in Kubernetes like persistence, all the functionality that's there to kind of gain agility even if they're still running a monolith. And I heard a pretty cool success story just before coming to this conference of a customer who did this with a huge code base they had that was Java, but they put Istio in front of it, and they pointed all of the routes to this one particular, we'll call it pod. But as they started to decompose that monolith, they would chip off little chunks of it, they'd throw it in their own deployment, and then they'd reroute Istio to point to that new functionality. So over the period of a year, they use Kubernetes to migrate an app from a data center to like full microservices, which is a really cool pattern. So this is totally valid if you're thinking, I'm not completely container native yet, can I use Amazon EKS? Definitely you can. And then 4th, although I probably should put this higher, relatively speaking, is machine learning. So if you would have told me, like April last year, that machine learning would have been one of the top use cases for Kubernetes on EKS, I would have probably not believed you. But I've been proved wrong, and it's really tremendous, the interest. So this is like TensorFlow-based workloads using GPUs, and this is all over the place, right? And so we have a lot of customers who are maybe using Kubernetes exclusively for this use case, which is really cool to see. And the community support for these frameworks is kind of even accelerating more. So I think that's awesome. So some specific references to customers. We have Fidelity, who is in the process of moving to EKS and building a PaaS, as mentioned, for their hundreds and hundreds of DevOps teams. Right? It's a big company. They span They're an international company, so they've got teams all over, but they're trying to build a unified platform. And their talk this week was kind of about their journey to, their desire to run 1 million containers on Amazon EKS. So it's cool to think about or hear about how they're thinking about this problem and how they want to scale for their developers and add agility there. So we also have Snapchat. I feel like this is, most people know what this is, but they run several of their primary features on Amazon EKS today. And Snap has been really, really critical in helping us shape our roadmap, kind of pushing the limits of our service and letting us know like where do things actually fall over. They're definitely a very large-scale customer. And these are primarily like microservice-based applications. And so they spoke this week in CON361, which is mastering Kubernetes on AWS. And you had an engineering lead from Snap and one of our BDs kind of talk about their journey and a little bit about the patterns that they're using here with Kubernetes and EKS. So that's a cool talk. I would recommend checking that out if you did get a chance to see it this week. And then we also have AppCard. So AppCard is interesting. They're a startup e-commerce platform, more or less. And so they build a platform for retailers. So they really like what Kubernetes offers, and they were basically looking for help in offloading the operational burden of both deploying and running the Kubernetes control plane. So this is something that allows them to, not focus so much on those aspects of Kubernetes, but really focus on just delivering value to their customers quickly through all the cool development features that Kubernetes offers. This is the one that doesn't have a talk this week. And then the final customer reference I have here is State Street Bank. And this is really cool. They are running high-performance databases that require really low latencies. So this is millions of queries per second, right? So State Street uses EKS because it really helps them minimize time on cluster operations, and they could really focus on eking out the last bit of performance they need, from high-performance EC2 instances for their databases instead of thinking about the nuances of Kubernetes, which is cool. So if like you're just waking up from last reInvent and you're like, what's happened in the past year? This is kind of a quick rundown of some of the important things that I think are notable. So in April, we achieved Kubernetes conformance for Kubernetes 1.10, or maybe it was 1.9 at the time. But this is something that this is the first time we did this. We achieved conformance for every version of Kubernetes that runs on EKS, and this is really important to us, that upstream tenant for us. We also were HIPAA eligible early on in the year, or kind of right after GA. This is great. We're kind of working on a whole bunch of compliance postures for EKS, and HIPAA was the first one for us. In July, we also released the build scripts for our AMI. August gave you new AMIs, although we've released several iterations of new AMIs. But this also came with a new CloudFormation template that kind of streamlined the worker node provisioning process. We also gave you a GPU-optimized AMI. We went through some struggles with the horizontal pod autoscaler and some upstream contributions to make that work the right way, so that was all achieved in August. We've been working on region rollouts, so in September and November, we brought you Dublin and Ohio. And then a couple of nice little things, so support for Istio, dynamic admission control, support for kind of dumping all the config from your control plane with the update kubeconfig CLI. We'll talk about how a lot of this works, but this is kind of what we've done until now, and we'll give you some hints on what you'll see when you get back to your offices next week from Amazon EKS. So let's talk about the control plane. And this is the part that we run for you, right? So what does the architecture look like in relation to your infrastructure? So the managed control plane, this is where we deal with all the stuff represented by the Amazon EKS logo here, and we just expose the whole Kubernetes control plane via that endpoint that you see, right? So you have a cluster endpoint dedicated to your cluster. It's really just Route 53. And we spend our time handling everything behind that endpoint, getting paged for things like etcd quorum failures or losing a node or connectivity issues between different AZs. If something like that happens, we're on the hook for that, and you're not, right? So ideally, you don't even notice a problem. And all you really need to focus on right now is the worker nodes, which run in your VPC. So there is this split account model, which is interesting. Kubernetes wasn't necessarily designed to run this way, which is why we had to talk about it. There's some cool stuff we're doing to facilitate that. But it's a really nice model for having a very secure implementation of Kubernetes, right? And that's one of our top focuses here. Also, if you're using any tooling, kubectl, maybe like a CI/CD system, you point this at that endpoint that we expose from our side. And just like your worker nodes, right? They also point at that endpoint from within your VPC. So today they do require outbound internet access to hit that endpoint. It is exposed to the internet, but it is protected by IAM and RBAC, and we'll talk about that too. So a little bit of more visibility into what's going on behind the scenes if we break open that, that icon I had there. This is the infrastructure for the Kubernetes control plane. And really what's important, I think, is that this is highly available and it's single tenant infrastructure, right? So you create a cluster, that's all yours. You're not sharing that infrastructure with anyone else, and you're getting all native AWS components, which means that you're getting real instances. You're getting a real network load balancer. You're getting an actual VPC. You're getting things like real EBS volumes attached to your instances. And we're setting up a whole bunch of monitoring and making sure that all these things are behaving as they should. We'll get paged if you start exceeding like the IOPS limitation on your volumes, for example. So all of this is under our purview right now. And you know, just showing you this, you don't have to think about it. Forget this slide. Is there anything else I wanted to talk about here? Oh, yeah, an interesting part about this, though, is because this is all native AWS, you could, in theory, run this exact same infrastructure yourself. But let's say you were a team running Kubernetes for other internal teams. This is actually a model that we would recommend using, and there's not really any secret sauce that we're using that you wouldn't have access to as an AWS consumer, which is great. So there's the potential for us to kind of maybe even open source this sort of infrastructure in the future, because it's all just, we think, best practices for running Kubernetes. Although we create and we manage all that infrastructure for you, there are still some elements of planning that you have to do when you create a cluster. So we're going to kind of walk through like some of the attributes on a cluster, the inputs you have to give us, and talk about why and how. And why do I have to go through this? I just want to press a button that says Get Kubernetes. But we have to know a couple of things. So we're going to walk through all of this. So the first thing is we need a role from you. And this is because we need to manage resources on your behalf. And if you've used AWS services before, this is a pretty normal pattern, this cross-account role. You basically give us a role that has some policies that we manage. So if you go into IAM and you filter policies for EKS, you'll see we have 4 different policies. 2 of them are applicable to the control plane. And so you need to take those policies and associate with them a role, or associate them with a role, and then give us that role for us to create your control plane. So one of the policies, the cluster policy, the service policy, first of all, is what we use for managing network infrastructure in your account. So like the network interfaces we create. And the cluster policy basically contains all of the permissions that Kubernetes needs to do things in your account. So if you think about it, Kubernetes does a lot of stuff for you, which includes like creating load balancers, EBS volumes, modifying tagging, kind of all the actions that exist in the core cloud provider code in Kubernetes. Those are the permissions we need. And so they're all defined in this policy today. And unfortunately, it is a lot of stuff. So I think when you see it initially, it's like, wow, that's a lot of things that Kubernetes does. But of course, if you want the value of Kubernetes, you have to give it the permissions to do so. So anyway, this is the first thing you have to give us, this role. And this allows us to manage things on your behalf. Those other policies are specifically for your worker nodes, which allow the nodes to do things, which we'll talk about also. There are also VPC requirements. So, I think one of the points of confusion initially is kind of like, well, you're running the control plane. Why do you need to give me a VPC? Like, why does that actually matter? And so you can think about this more as like the VPC that your stuff is going to run in. This is the VPC for your Kubernetes data plane. So load balancers, worker nodes, give us all the subnets that you're going to use for that stuff. And this could be all private subnets. It could be all public subnets. We generally recommend a mixture of both, especially if you're going to do things like run your worker nodes in a private subnet, run your ELBs in a public subnet, right? That's a pretty standard pattern, and that still applies to Kubernetes. The reason that you give us these is well, first of all, we can tag them, right? So we actually tag the subnets with kubernetes.io/cluster/cluster name equals shared, and this is just a Kubernetes requirement, right? So this is also something that kind of exists in the Kubernetes, the Cloud Controller Manager code. This is just how it works in AWS, right? So this is kind of just a stock requirement. Similarly, if you want to use internal load balancers, there's a couple of annotations you have to use. You can put this tag onto your subnets that will hold internal load balancers, and that's how Kubernetes will discover where to actually place that on your behalf. So there are some additional things to think about with a VPC. So you do have to plan ahead with your subnet sizes, right? So I know a lot of default things in VPC setups. You see like a /24 for your worker nodes or for EC2 instances, right? And that's fine if you're not going to run a whole lot of instances. But in the case of Kubernetes or an EKS specifically, where we actually allocate a pod or an IP to each pod, you probably need a slightly bigger subnet, right? So if you have a /24, that's 254 IPs. Let's say you want to run a 20-node cluster, so then you have 234 IPs left over, and that means you can run 234 pods total, right? So I'm just doing some rough math here, which probably it's too early for. But I think the gist here is a /24 is probably too small unless you're running a very small cluster. So our default templates give you a /18 if you want to use our sample VPC template. And we'd recommend thinking somewhere in the range of that CIDR block size, because as your cluster grows, you really don't want to have to like recreate your cluster in a new VPC just because your CIDR blocks were too small in the first place. The security group, I think this is something that is maybe also a little confusing at first because you guys are managing it. What do you mean security group? How does that actually apply? And this security group defines the connectivity between the Kubernetes control plane, so what we run, and the worker nodes that run in your account. So we create ENIs in your account, and this is what we apply to those ENIs. So this kind of restricts the access to and from those ENIs. So at a minimum, what you need to do, Kubernetes needs 443 inbound to the control plane, and then our control plane needs 10250 outbound. So 10250 is the port that the kubelet listens on, and this is how we reach out to the kubelet for certain operations. 443 outbound from your worker nodes, obviously, is so you can reach the HTTPS endpoint that provides the Kubernetes API. So there are two security groups you have to think about in the EKS setup process. There's the control plane security group, there's the worker node security group, and that worker node security group and the control plane security group have to have permissions that align, right? So if there's like an explicit deny somewhere, that can get confusing and you can run into problems. Another thing you have to pass to us when you create a cluster is the Kubernetes version. So when you get back home, you'll have the ability to create a new cluster with 1.11.3. And just a little commentary on our Kubernetes version strategy. We're going to be in line with the community and support up to 3 versions of Kubernetes at once. And after we have 3 versions in production, we'll deprecate an old cluster. And all we mean by deprecation is you can no longer create a cluster on that deprecated version. But if you're running it currently and you haven't updated yet, that's OK with us. We'll probably reach out to you and ask you a little bit of questions, though. I think you'll see a much faster delivery of Kubernetes versions in 2019 from us, which is something that is highly requested. So duly noted, and this is something we're really focusing on. We've been doing a lot of the groundwork behind the scenes to make sure that we can do this quickly and reliably for you. I also want to talk about these. There's one other version construct in EKS, which is the AWS EKS platform version. And this is something that is a representation of customer-facing API changes, or if we add a new patch version to a specific Kubernetes version, these will increment the platform version. And the intention behind this is to say, hey, something has changed on our side. You should be aware of this. Test your applications. Make sure that there's been a change. We might have enabled new emission controllers, something like this. So we added an EKS.2 platform version to Kubernetes 1.10 to introduce the horizontal pod autoscaler support. And then we auto-updated those for you. But I think it's important to realize that platform versions increment within a Kubernetes version only. So we started on 1.10 with EKS.1. We added EKS.2, which was that horizontal pod autoscaler. When you get back, you'll have Kubernetes 1.11 with its own EKS.1. And then in the future, you might see something like EKS.3 for 1.10 if it revs the platform or the patch version. And then if we introduce 1.12, that'll also be on .1. Yada, yada, as we add new functionality to older versions, EKS.2. This is really only to give you context on, has the configuration of this particular version changed since I started using it, right? And to kind of give you control over that iteration. So platform versions are not the same across all Kubernetes versions. It's only to let you know about changes within that version. And in our documentation, you can look at the actual API server configuration for that platform version. So we actually just give you a dump of all the enabled admission controllers for that platform version. And any release notes that are relevant for you to know what comes with that new version. So maybe the patch version will increment, maybe we'll add functionality, maybe we'll change admission controller configurations based on your feedback. And you can find this all in our documentation. Another thing you'll have when you get back home is Kubernetes version updates. So we have a couple of new APIs to support this functionality. So we have the update cluster version API, and this is an API you control, which supports an in-place, zero downtime update of the Kubernetes version running on your cluster. So because we run that HA infrastructure behind the scenes for you, you can continue to interact with your cluster while the update is in place. This takes about 8 to 10 minutes. And it also introduces an update EKS API object, right? So in the context of your cluster, you might have multiple updates in flight. Today, we only support one type of update, but you may have additional ones in the future. And so you can use list and describe update to provide visibility into the status of that asynchronous job effectively. So you'll kick off an update, you'll be able to describe the status of it. And let's say, for example, you've done something like accidentally deleted the role from your cluster. If we can't update your cluster for a specific reason, like there's no role associated with your cluster, we'll tell you about this. And so you'll get specific error values from describe update. I also wanted to talk a little bit about the security posture of the control plane while we're talking about the control plane. So this hasn't changed any from last year, but the idea here is that we have integrated AWS IAM with Kubernetes RBAC effectively. So we split the responsibilities of authentication and authorization. So in kubectl, we have an external authentication binary called the AWS Authenticator. For now, it's an external binary. But this allows kubectl to pass your AWS identity to the Kubernetes API server. So what that means is that kubectl can look in the exact same credential chain as the AWS CLI. So it can look at your session token, it can look at your environment variables, it can look at your secret and access keys or an active role, something like that, packages it up, sends it to the API server. Kubernetes doesn't really know about that, so we have a webhook authentication system behind the scenes that verifies the identity as a valid user, valid ARN for your account. Could be valid role, valid user. So the authentication here is still handled by IAM, but the actual authorization is handled by RBAC. So Kubernetes looks to see if RBAC has an entry for that particular user, and if you have permissions to make that kubectl call, it'll approve or deny that action. So we've kind of split those responsibilities to kind of make it easy to think about the distinction between these two different systems. Mashing authentication systems together is kind of difficult, so this was the cleanest way for us to do that. It's also important to note that each cluster is a unique CA, so we manage this for you also. The PKI setup in Kubernetes is not always the most fun to manage long term, so we do this for you. So we use the built-in Kubernetes CA system, and we generate a set of certs for the control plane. The kubelet can also get certificates by issuing a CSR to the API server, which generates public and private keys, and then the kubelet knows how to work with those and install those on itself. And kubelet's also set up to have certificate rotation, so we're constantly refreshing these. I forget what the refresh period is, but this is something that's handled for you. So just a little bit of note about the security configuration. This is a high priority for us. As mentioned, we're already HIPAA eligible, but we do have additional certifications coming, again, when you get back home, all of these different flavors of ISO and PCI DSS, and we're also working on any other compliance certification you can think of. So if you have questions about that, feel free to reach out to us, and we'll give you the rundown. So when you get home, these will be there. So let's wrap up the control plane section. Basically, to get all the config that you care about from the control plane, we have a CLI helper, which is update kubeconfig. And this just dumps all the information, like the certificate data, the cluster name, basically creates a kubectl or a kubeconfig context for you for your cluster. And if you have a file already, it will just append a new context with the contents for your cluster. So everything about the control plane, wrap it up, dump it to a kubeconfig file, and you're ready to go to start using it. So moving on to the data plane, this is the stuff that runs in your account. Let's give you all you need to know about this. So I think one of the first things we want to highlight, I've got an extra check mark there, is that you have a lot of instance flexibility, right? So although there's a little bit of heavy lifting on your part, we give you a CloudFormation template, we give you an AMI, you still have to stand them up yourself. But the trade-off that we've made there for the time being is that you do get a lot of flexibility in this case. You are not limited on the instance types you bring. You can bring a combination of whatever instance types you want. So we have a lot of customers using P2s and P3s for GPU workloads. We have customers running i3 Metal instances. Our AMI works with this. Customers using Spot instances, EC2 Fleet. This is all available for you to use, and it works with EKS today. You can also bring your own OS, and this is a QR code that links you to this GitHub repository. Also pretty easy to type in yourself. But the idea is that you can bring your own OS, and although we do build you an AMI, you're not required to use it, right? So you can, we have customers using, we'll just say every OS that you can think of. And the way that they're able to easily do that is because these build scripts are the source of truth for that AMI. So anytime we modify the AMI, we also update the GitHub repository. I guess actually the inverse is true. We update the GitHub repository, and then we rebuild our AMI, because this is the source of truth. So it's a HashiCorp Packer script, our build scripts, and there's assets for each supported Kubernetes version. So if you look out for 1.11, this will hit the GitHub repo pretty soon. We also have a supported AMI from Canonical, so they have an EKS optimized AMI that they build and maintain, and it mirrors the configuration for the most part of what we build for the Amazon Linux AMI. So you have options pre-made from us and from Canonical, and whatever you want to do with this is up to you. We also give you an AMI to easily take advantage of GPU instances, right? So the hardest part, in my opinion, is getting the NVIDIA drivers set up the right way for the different instances. That's not exactly fun, so we package all of that for you, and we keep it up to date. And this is in the AWS Marketplace. So what you have to do is you have to go to the Marketplace, you subscribe, and then you can go launch them into a worker node group in your EKS cluster. So this is if you're running TensorFlow, if you're using libraries like CUDA or CUDNN, the neural network software from NVIDIA. This all just kind of works right out of the box. So we have guidance in our documentation on how do you get like the NVIDIA SMI library going, and you can see all the GPUs on the P2 and P3 instances through Kubernetes. Super straightforward, but as soon as you start getting into training models, then I don't really know what you're doing, so I can't help you there. And then for bootstrapping your worker nodes, you have a couple of options. So we do give you a CloudFormation template. You can also use our bootstrap.sh script, which is in the CloudFormation, or which is in the GitHub repository. And this just allows you to do things like tell kubelet what's the cluster name that it should be joining. This kind of removes basically you can run this script and pass cluster name in just the user data for a single instance if you want to, and that instance will join your cluster. It also allows you to pass flags to kubelet to modify its configuration at boot time. So this could be things like defining max pods. There's a ton of bootstrap arguments that kubelet supports, and they're all supported directly through this bootstrap script, which is nice. This is also extensible to our CloudFormation template. So there is a parameter called bootstrap arguments, which allows you to feed these arguments directly into that bootstrap script. So from the CloudFormation, you can throw things, two examples here. First, the parameters are passed to bootstrap.sh. This is how it looks. And then basically the result here is you can modify the configuration kind of at scale across all of your instances, the kubelet configuration, through these arbitrary kubelet flags through CloudFormation, which is really nice, right? So you don't actually have to go in and write any custom scripts to do that. And part of our goal here is just giving you more flexibility on how things are configured. It's really up to you how you define all of this. So one important thing here is the authentication component. All of the bootstrapping of the instances that you do, checking all these things into the cluster, they all have one common thread, and that's that you do have to tell the cluster, hey, you should let this IAM entity join as a node to my cluster. So the way that that actually works is there's a config map for AWS auth on the cluster, and we have a group for the nodes, and you basically tell it the ARN of the role for the nodes that should join, right? And so anytime you add a different ARN, if you add a different node group that's in its own autoscaling group that has its own role, you have to tell the config map about this. And so right now, this is kind of a manual entry process. You have to go in there, drop that ARN into the config map, save it, but as soon as you save it, you'll see that boom, 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 all your nodes start joining the cluster right away. So this is basically to prevent unauthorized access of nodes that you don't know about joining your cluster. So we mentioned Kubernetes version updates. You still will have to use CloudFormation to update the worker nodes today. And we'll be giving you some extensive directions in CloudFormation depending on kind of the nuances of your application. There's always some care and feeding that's going to be required if your applications don't really tolerate, if they're not fully stateless, right? If they don't tolerate interruptions well. Because if they're fully stateless, you can probably just do things like update the AMI or kill all the nodes and drop new ones into your cluster. But if you have some more specific requirements for gracefully draining applications, we'll give you instructions on how to do that using things like kubectl drain. Make sure all of the pods are gracefully terminated on your nodes before you go ahead and move them over to a new set of nodes. So look out for this. There's actually, in my demo later on, we're going to show you how updates work. And there's a documentation link in the console directly to the process here, how to do this. Let's talk about networking just a little bit. And so I think this is, depending on your interest level, this is this can be a very deep topic. There's a lot of things that Kubernetes brings in the networking space, and EKS tries to make a lot of this easy. But maybe at the expense of making you know more VPC networking than you did before. So we do, our goal is to make EKS integrate Kubernetes with VPC networking as best as possible. And this is simpler for folks who know VPC networking, but if you're used to just maybe an overlay network, there are some things to kind of adjust to and learn about. So we have our own CNI plugin, and we're going to talk about how that works. Oh, first slide, though, is here's how our cross-account networking works. So we have two VPCs. We have the customer VPC on the left. It's outlined in green. There's worker nodes in there. For outbound internet access, or for access into the cluster, they reach out through the internet to our network load balancer that exposes that Kubernetes API endpoint, and that sends communication to the API servers running in Amazon EKS. That's all within our VPC. However, there are commands in Kubernetes like exec and logs and proxy, where actually the kubelet is the server, and the API server on our side is the client and has to initiate a connection to the kubelet. So we need access into your VPC in order to do that. And the way that we get that access is we actually provision an ENI that we own in your VPC. So if you look at that object, the ENI object in your VPC, you'll see that your account is the owner for it, but there's a separate owner, which is the attachment owner, and that's one of our accounts. And we basically attach this to one of our API servers on our side, and then we have a route into your VPC, which allows us to say for anything that needs exec logs proxy, we go out over this route into your VPC, and this is all encrypted with SSL, right? So this is all TLS. Kubelet is listening on a secure port only. We also have a CNI plugin. So we saw a little bit about the networking on the master instances, but let's see how the pod networking works. So this is what runs in your account. And this is kind of critical to understand how your applications kind of communicate to each other and to external resources, right? So as part of EKS launch, we announced the CNI plugin, which is an open source project. It lives on GitHub. The repository is linked here. It's called the AWS VPC CNI. And this is something you can use on your own. It's not only for EKS, but there's folks using it in KOps, for example. So it's in KOps if you want to use it as for experimental purposes or for development, whatever. So one of the tenets of the VPC plugin is to provide first-class networking support for AWS for pods and Kubernetes. And so this basically means that every pod in your Kubernetes cluster gets a native VPC IP address. So one of the benefits of this is for debugging purposes, you can go directly to your pod. Load balancers can go directly to the pod IP addresses instead of going through a node port, which requires an additional hop. So there's performance benefits here. We've had a couple of customers tell us things like, hey, we've actually shaved a couple of milliseconds off of our application response time by switching to your CNI from an encapsulated overlay, which is really cool. So the CNI plugin attaches an ENI on demand to the worker nodes where the pods run. So it then uses secondary IP addresses by calling EC2 associate address to the instances. And you can kind of control how many are allocated at once. But this basically this approach allows us to get more pod density per instance. So if you look in the EC2 networking documentation, you can see for different instance types, they can support different numbers of ENIs per instance. And as instance types get bigger, the ENIs can also support more secondary IP addresses. So if you have like a T2, you might be looking at 2 ENIs total and maybe 6 or 8 secondary IPs total. But as you get up to something like, I don't know, an R5 XL, you have 15 ENIs and you have 30 or 40 secondary IP addresses per ENI. So the pod density scales with the instance size naturally. So in this workflow here, as pods are scheduled onto the nodes in your cluster, the CNI, there's a plugin, or there's a component of the CNI that's responsible for actually wiring up the network interfaces for you. So these secondary IPs get attached to an ENI, and the CNI plugin knows how to say, OK, when a pod is scheduled, I'll actually take this IP, and I'll wire it into the pod. So what does this mean? This basically means that, as mentioned earlier, you do need to size your VPC appropriately for this kind of IP address consumption. And this might be problematic in certain situations where maybe you have a legacy network or you're using all of the 1918 space in your network. Maybe you're an ISP or you have a network from the 80s, something like that. Not a joke for real. And maybe you're saying, I can't allocate a bunch of IP address space from my VPC. So what can I do in this case? So there is a new feature in the CNI plugin, and I think 1.2 or newer. We just released 1.3 before we came to this conference. But this allows you to set up what we call custom networking for pods. So if you're familiar with the VPC, you can actually do things like add secondary IP addresses to your secondary IP ranges to your VPC. So you can extend your VPC network with either additional private IP address ranges or alternative IP ranges like the CGNAT space. There's spaces like 198.19.0.0/16. So there's a VPC documentation page that kind of tells you all the different ranges that are supported by the VPC. But what you can do now is you can add these ranges to your VPC and not consume space out of your private IP space, and you can tell pods to actually use these IPs only. So this is done through the custom networking support in the CNI plugin. And there's a couple of steps you need to do to get this to work. So first of all, you need to enable the feature. And this is just a key value environment variable in the AWS node daemon set. AWS node daemon set is the CNI plugin, right? You then also need to deploy a custom resource that's responsible for actually applying the custom network configs to your pods. And then you can create a custom resource definition, which we call an ENI config. And there's some metadata. You give it a name. And you basically say, what subnet should my pods get an IP address from? So when you add that secondary range to your VPC, you can create subnets in that secondary range. Once those subnets exist, you can drop your pods into them, basically. And then finally, to make the nodes actually use this custom config, you just need to annotate the nodes. So this is just a little bit of additional metadata. But once this happens, then you have the ability to support much more advanced networking configurations. And I've dropped a couple of slides from this because we had some really in-depth discussions on like CNI using like source natting and everything like that. I'm going to move on from that stuff and instead just talk about how does this help you support advanced networking architectures with EKS. So in this case, you might have a corporate data center, many of us do, and that has a 10.IP range. We're 10.1.00.16, but we also have a VPC, which can support multiple IP ranges. So let's say that our primary subnet is a 10.0, and we need to make sure that these have connectivity always, right? Because you might have applications on-prem that your pods need to speak to. You need full connectivity between these things. So you have something like a customer gateway, you've got a VPN or direct connect, and you want to make sure these things work because you're paying good money for them. So in the case where you have an EKS worker node, the primary ENI basically always remains on the primary subnet in your VPC, right? This is to make sure that the worker node can communicate using like the default route table, all the default things for your primary subnets in your VPC. And this would also ensure that we have communication back over to your on-premise data center. When you have a secondary subnet added to your VPC, the worker node can span this by adding an ENI and adding a pod to it. So when those pods get scheduled, they get an ENI dedicated to the, from the secondary subnet dedicated to the pod. And we're using the 100.64.0.0/10 CGNAT space. So we can just assign a bunch of IPs to pods from this particular subnet. So this is all well and good, but you might be thinking, like, what about those pods? And they need to reach out to they still need to reach out to the on-prem data center. How does that work? So we do what's called source natting. I'm sure people are familiar with that. But the default behavior for the CNI plugin is to do outbound source natting and make it look like the traffic coming from the secondary IP on the pods is coming from the primary ENI on the instances. So this means the egress behavior for those pods is no different than if it was coming from just like an application running on the host using the primary ENI. That source netting behavior basically has the hypervisor underneath do all the connection tracking, so the return traffic also works just fine. You also have the ability with the CNI plugin to toggle, like, should it do that source netting by default? So you have a lot of control over how do the pods traffic look when it's leaving the node and when it's leaving my VPC. So if you have some additional requirements on how to route that traffic, we can support you, and there's a lot of knobs basically hidden, not hidden, documented in the CNI plugin documentation today. So if there's interest in talking about this sort of stuff, we'd love to work with you on it. We've been seeing more and more of these sort of things, creative networking infrastructures, additionally working with things like the transit gateway and VPC. At the end of the day, this is all native VPC networking, so if you're not a VPC network engineer, it can be a little bit daunting because we're just mapping it to Kubernetes. But at the end of the day, it's really all just VPC, so that could be a benefit or a negative depending on your perspective on how good you are with VPC networking. I'm doing pretty good on time, so I'm definitely going to make sure I have time for some questions afterwards. We'll hang out down front, and we'll talk about this. We've got a couple of extra sections here about load balancing that I want to talk about. And at this point, we now have support for all three networking options or load balancing options in Kubernetes. So obviously, the classic load balancer is the default. That's the one we all know. If you have a service of type load balancer in Kubernetes, Kubernetes says, OK, I'm going to go ahead and create that, and I'll attach it to your service, or I'll attach it to the pods that run in your deployment. The classic load balancer is great, but there are new options that are kind of just now becoming well supported in Kubernetes. So the network load balancer is a layer 4 load balancer, and this is basically a drop-in replacement for the way that Kubernetes uses the classic load balancer. So the NLB is an option for when you create a service of type load balancer, and it works much the same, although it's higher performance. You get cool features like static IP addresses, and it's really purpose-built for layer 4 use cases. So the other thing I would add is that you can use both internal and external load balancers with Kubernetes and with EKS. This sort of setup is no different than if you're using Kubernetes upstream or running it yourself on EC2. EKS supports it in the same way. So let's look at how that actually works. So it's all annotation-based, right? When you actually create that service that says, I would like a load balancer, please, Kubernetes, you just add a couple of pieces of metadata. So when Kubernetes goes off to create that load balancer, it has instructions for how to do it for you. So the first important one is the internal load balancer annotation. You must add this, and you must also have a private subnet that Kubernetes knows about for this to work. If you add this annotation and EKS only knows about public subnets, you're going to get a failure in placement of your load balancer. So as long as this is there, there's a private subnet with the appropriate tag on it, Kubernetes will create the internal load balancer for you. If you also want to use a network load balancer, this is again an annotation on your service. So same way that you would do it for an internal load balancer, you just have to specify that you want to use an NLB. This is a beta annotation, although it's probably alpha in its implementation. It's relatively new. It does work for basic use cases, but there's also still edge cases where that functionality might not be there for you yet. So this is being evolved. You'll see us continue to add functionality to this as we get through later Kubernetes versions. I would say probably 1.13 or so is where we'll see a like a proper beta for the network load balancer. Then we also have the ALB Ingress controller. So this is something that's existed for a while. The history of this is basically our partners CoreOS and Ticketmaster wrote this a long time ago, and we were very interested in the design approach. It's a really nice design that kind of gracefully maps the ALB to the Ingress resource or API in Kubernetes. So Ingress, if you're not familiar, is really the layer 7 abstraction for Kubernetes, and it maps really well. There's a lot of other options for Ingress like Nginx, but ALB fits really well for this model. So this is something that you can check out on GitHub. The development's done all in the open, and we actually have a bunch of customers using it in production today. I'll say a handful of enterprise customers running production workloads on it, which has been great, and it's helped really accelerate the development for us and pick the right things to work on. So this has existed for, I would say, probably a little over a year. And we've put a lot of work into it over the past couple of months, added a bunch of things like test coverage and making sure it's just like a robust production-ready code base. So if you want to use this in production, we will support you with it. If you run it on EKS and you run into an issue, you can cut us a support ticket. This is part of the service now, and this is our official recommended way of using the application load balancer. So it's here. So let's walk through how this thing actually works. So this enables you to expose applications inside the cluster as an external HTTP or HTTPS service, right? The ALB Ingress controller does this by integrating these applications with the ALB, just exposing them through the outside world. This really relies on the ALB to provide all of the content-based routing functionality. So to use the ALB Ingress controller, you would first deploy it as a deployment on one of your worker nodes. So this is just a little app that watches the API server. It just spins and looks for notifications from the API server, essentially, that says, hey, someone's created an Ingress resource. So you can think about an Ingress resource as being analogous to like a service resource or a service definition when you create a regular load balancer. And what this does for you is it specifies that I would like an ALB, and then it also specifies things like what routes should it have, what subnets, what security groups. There's a bunch of AWS abstractions in this Ingress resource that are required for the ALB Ingress controller. But you can think about creating an ALB just through the console. The same sort of information is needed by the Ingress controller. So when you create that Ingress resource, what actually ends up happening here is the Ingress controller kind of kicks in and starts creating the ALB for you. So it looks at all the configuration, looks at the service it needs to connect it to. And so it will do something like create an HTTPS listener, depending on what you specify, and it will create what's called a rule. And so this is your route. This can be a path or a host route. And this points to a target group. So bear with me here. There's, a target group is a load balancing abstraction for us, and this just specifies like which instances or which IP addresses live behind the load balancer. We're going to call this instance mode, because the way this actually works is the traffic is routed to the node ports on the nodes in your cluster. So This means that kubeproxy will work here behind the scenes and find out how to get this traffic to your pods. But this is one of the modes the ALB Ingress controller supports. We'll call it instance mode. So our charcuterie route here, if you need information about delicious meats, goes through our blue application through the node port. You could also have another listener here, the HTTP listener. Although it's not required to have separate listeners, you can have the same one on the front end, but you can have different rules behind the scenes. So our cheeses application here. The important thing about cheeses is it's probably going to have a little bit better application performance than the charcuterie application because it's using what we call IP mode. And IP mode points directly to the IP addresses of the pods running in your service. So remember those VPC native IP addresses that we give you with our CNI plugin? These are checked into the load balancer. So when you look at the target group configuration in these different modes behind the load balancer, you'll see different things, right? So you'll see a bunch of either instance IP addresses with a high-level port mapping, like node port, or you'll see a bunch of IP addresses that directly map to the pods running in your service. So you have the option of both. You can kind of mix and match. This is a very flexible tool, and we're really excited to have this available for you guys. So highly recommended. Pick this up if you're looking for a way to do some layer 7 content-based routing functionality in Kubernetes. This works great. So a quick recap. We went GA for production workloads in June after running a long preview. Important stuff, the ALB Ingress controller is now 1.0. It's open source. It's ready for production workloads now. Go ahead and grab it. It's a single deployment to get it on your cluster, so fairly straightforward. We do have new features coming, so as soon as you get back home from reInvent, you'll have Kubernetes version updates and Kubernetes 1.11.3 for new clusters. And you can begin updating your existing clusters to 1.11. And then also compliance, so we are HIPAA eligible today. You have ISO and PCI coming soon. And again, you'll have that when you get home. And then I want to give you one more thing, which is that we know that global availability is really important for EKS customers. We started with only Virginia and Oregon. Recently, we added Ireland and Ohio. And then watch out, APAC. Coming soon before the end of the year, you'll see Singapore, Sydney, Seoul, Tokyo, and Frankfurt available for EKS. And we'll kind of continue this velocity, adding a bunch of regions through early next year. So if you don't see yours here, we're going to get to you, I promise. So I've got a little bit of time. I want to go into a demo for updates, but I need to make sure my machine, I think it hibernated, so give me a second here. Cool, so I have a couple pods running on a cluster. This cluster is my Pineapple cluster here, which is, can we see that? Cool, so this is running 1.10 today. We've also had kind of a refresh of the EKS console, making it a little bit easier to use, adding additional details, giving you direct links to like the networking resources for your cluster. We're going to keep working on this in the really slick new design language for the console. You'll see kind of all AWS services move to this over a period of time. Love having it by default, though. So you'll notice something different here. There is an update cluster version API available for you. So let's look at what this actually looks like to walk through. So pretty straightforward. We have, of course, 1.11 as the only option today. But this is what we can update to. So let's go ahead and kick that off. And we're just going to type the cluster name to confirm that we actually want to do that update. It is an irreversible action. There's no rollback today. So I think one of the things we want to call out is that if you're going to be doing this update on your production cluster, we'd highly recommend that you also run your applications on a test cluster and do that update not in production. Make sure that you're not dependent on a Kubernetes API that's going to change significantly between these versions and catch you by surprise. So highly recommend building this into a CI system or something and have this testing framework in place. I find that the more of the Kubernetes API surface your application touches, the more likely you are to run into issues because things change so dramatically between Kubernetes versions. So just be aware of that. Let's confirm the update. And so here we go. We've got a flash bar telling us the cluster version update is in progress. Here's the link to the documentation for your worker nodes. You can, of course, run worker nodes in kind of a mixed configuration. Kubernetes backwards compatibility is pretty good. So you can run 110 nodes with 111 control plane, although you might have some unpredictable behavior for new APIs and stuff that's changed between those versions. So what we want to look at here is down here, we actually have the update in progress. And so we can get information about this update ID. So this is a new API object. This is an asynchronous job that's happening behind the scenes. We have the job type, we have the submission time, we have the status. So we can actually come in here and get additional details about this update. And if there were any errors, for example, like if I had, if my cluster was in a degraded state for some reason, I deleted my VPC, you'd see that show up here and it would tell you specifically why that would be a problem. The only thing I wanted to show, 1 second here. So if we go back to my worker nodes here, we can still see that the cluster is responding, and we can do something like see that we're going to exec into the BusyBox container and also curl my Nginx application and see that my apps are still running during this particular upgrade process. So this is a fully online application version update. Your apps will still run, and we're doing this in a very steady and measured way behind the scenes to make sure there's no connectivity interruptions for your control plane. So that's it for me. I still have 9 minutes left, and I think we have some time till the next session starts. I would love to hear questions and meet you guys. Thanks for coming to this session this morning.